Hi guys, here we are. This is the last section of Unit 16, which is our last unit for the year, and we're going to be talking about pH and pOH. So these two are kind of the opposites of each other as far as what the numbers mean and what they're measuring and all that kind of stuff. But basically what it is telling you the concentration of either the hydrogen or the hydroxide in a solution. And pH itself stands for the power of hydrogen, and it is a mathematical function. It's the negative logarithm of the hydrogen ion concentration. And we're going to do some practice problems on it in a minute, and basically it's just knowing how to use your calculator. So the math itself is not a big deal, but I do want you to know that there is a mathematical background to it, and I'm not Mrs. Hawkins, so I can't really go over the logarithm and what all that means, but that's where it comes from. And from these calculations, we get our pH scale, and they are kind of inverse of each other, like I was saying with hydrogen and hydroxide. And because of that, we base everything basically on 7. In neutral solutions, you would have equal amounts of hydrogen ion concentration and hydroxide ion concentration. And if you did the math behind that, you would find that the pH equals 7 and the pOH equals 7. And so that neutral and those two numbers equaling 7 is where we get our 14 for the pH scale. That's the biggest number that you could get to. And so when you are looking at pH or pOH, you will see that they are very related to each other. And so that's what this little graph shows, that they kind of seesaw back and forth, and they always together will equal 14 essentially. And so as one goes up, the other will go down, and vice versa. And that is and the relationship between those two numbers. Now we do base everything off of pH, I suppose, just because we had to choose one. We could base everything off of pOH as far as acid or base. It would just have kind of flipped everything around as far as how the numbers go. But so on this little scale, as you can see, the lower number, so everything below 7, is acidic. Right at 7, you have a neutral solution, and anything above 7, you would have a base. And so they show you some of the powers on there, and that is the relationship, and the equations that I'm going to show you on the next page are based on that in part. Okay, so here are the actual calculations. So what are you finding, or how do you find pH, pOH, or the concentration of H or the concentration of OH? So all of those things you will need to be able to calculate using a calculator. And so depending on what type of calculator you have, you will have to punch things in a little bit different. I am going to do an example problem, of course, on the next page, and I will kind of run you through how to punch in certain things. The one calculator that I have trouble using still to figure out pH or pOH are phone calculators. Somehow you have to put them in exactly right in a phone calculator to get the right answer. So you are welcome to try and figure it out on your phone. Otherwise, I will tell you how to do these calculations on a simple calculator like the ones that I have in my room, or a graphing calculator if you have one of those at home. But anyway, if you're finding pH, there are two ways that you can find it. You could find, if you know the hydrogen ion concentration, you can take the negative log of that hydrogen ion concentration, and it will give you pH. Now, if you are using a very simple calculator, so I don't know if you can see this, so here's one of my ones that, there it is, that you would use if you were in my classroom and needed to borrow a calculator. For those, when you punch in those numbers, you actually punch in the hydrogen ion concentration, then you hit the log button, and then you drop the negative sign. So you basically punch it in exactly backwards from what the equation gives you. So that's one way to find pH. Another way to find pH is if you know pOH. And so If you know pOH, your pH would be found by subtracting 14 minus that pOH minus the known. So on your, let me mark these on here. So you have to know either H if you're going to use the log, or you have to know pOH if you're going to just subtract. Okay, so you have to know something or have a starting point. Then to find pOH is basically the same thing, except now you reverse it. So if you want to find pOH, you would have to know the concentration of OH and then take the negative log, or you would have to know pH and then it would be 14 minus that pH. And just know your answers can have decimal points on them, but they will always be between 0 and 14. Now, if you're trying to find the concentrations, these you can find only if you have either pH or pOH. And to do this, you're going to use the second function button. For most calculators, at least, it's the second function on the log key, and it is the 10 to the x. And so you would, again, in one of my really simple calculators, you would punch in pH, you would make it negative, and then you would do second, and then do that 10x function. And you will usually with those get numbers that can have a really wide range. You could have whole numbers, numbers greater than 1, as well as numbers that are like in scientific notation, like times 10 to the negative something. So that one's pretty wide range. Then finding the concentration of OH, same thing. You would have to know, let me circle those again, you would have to know the negative pOH and punch it in, make the negative, or put the negative sign on, and then do the 10x function. And so for each of these, like I said, as long as you've got a calculator, you're good to go. But for some of you, it will be working the calculator. Now, I didn't say anything about the graphing calculators because I think they're pretty easy. And some of you will have kind of the in-between calculators that will be able to do them this way. But with a graphing calculator, you would just punch in the equation as is. And so up there to find pH, you would put in the negative log of the hydrogen concentration. So you'd punch it in exactly the way the formula says. All of these calculations or all of these how-to finds would be good to put on your periodic table. And that way you still have that as a reference for whatever future chemistry classes you are planning on. Now, one other thing that I have written on there, most times you will be asked to determine if this solution is acidic, basic, or neutral. And the easiest way to do that, because of the values and the scale that we use, is to use the pH value. And remember that if it is acidic, it's anywhere between 0 and 6.9. Basic is 7.1 to 14. And then neutral will have to be exactly 7. So when we do this example, that's kind of what we'll look at. And then on the practice problems that I give you, that's what you want to look at also. Okay, so here is our practice problem. So it's asking you to find the 4 components, the concentrations of hydrogen and hydroxide, the pH value, and the pOH value of the solution. And first thing it does is basically tell you the H concentration. So it says that you have a solution that has a concentration of 0.0004 molar HCl. And I'll be more specific than this on the problems that I give you. But hydrochloric acid is a strong base, which means the concentration of the acid itself is also the concentration of the hydrogen. So I know that my H concentration is 0.0004. On the problems that I give you, I will give you that number already, or I'll give you one of the other numbers. Now, to find pH, that is where I'm going to need to take the negative log of the concentration of H, which is 0.0004. And so you're going to punch that into your calculator, and you will get a number, and you should get, and I'm going to round, you should get somewhere around 3.4. Okay, so depending on your calculator, you may need to punch it in several different ways. So I'm doing this partially just to show you, how the problems work, but also so that you can practice with your calculator. So 3.4 is what you should get for pH. Then the next one that asks you to find is pOH. And so this one, the easiest way to do that is just subtract. So 14 minus our pH value, which was at 3.4, will give you 10.6. 10.6. All right, so now we've got the first three components, and then the last one. So this is where you're going to use the 10x function. And so you're going to have 10x, and you're going to do that for negative pOH, which is that 10.6. So 10x and to the negative 10.6. So punch that again into your calculator, and you're going to get, it may take you a few times just to make sure you get the process right on your calculator. You're going to get 2.5, and I'm rounding, so it may have a few more decimals on there, but 2.5 times 10 to the negative 11. So these are for you to practice on. So make sure that you know how to use your computer or your calculator and kind of which way to plug stuff in. Okay, so now I didn't put it on here, but I will on the problem. So is this solution acidic, basic, or neutral? And remember to figure that out. You're always going to look at pH. And your pH is 3.4, so it is on the lower end of the scale, which means that overall you have an acidic solution. All right, so I'll give you a set of practice problems for these tomorrow or tonight sometime. So make sure that you practice up, check with me on your answers and all that kind of stuff. I'm not going to give you the answers on this practice because there's no real way for you to show work, and so make sure that you check with me if you're not getting the right stuff on your calculator using this example. All right, guys, have a super good day. I will talk to you again. See you later.